Hello everyone, welcome back to my YouTube channel. Today we are going to discuss an important topic in lean manufacturing, bottleneck analysis. A bottleneck is any process, machine or operation that limits the overall production capacity of a manufacturing system. Just like the narrow neck of a bottle restrict the flow of liquid. A bottleneck restricts the flow of production. So today we are discuss with everything what is bottleneck and how to operate in lean manufacturing. So bottleneck analysis in lean manufacturing. In lean manufacturing, a bottleneck is any process, machine, workstation, or activity that limits the overall production capacity of a system. It is the slowest point in the production flow and prevents the factory from producing more products, even if all other processes were faster. In simple definition, a bottleneck is the weakest link in the production chain that restricts the flow of work. Everyday example, imagine a highway with four lanes that suddenly narrow to one lane. So traffic build up before the narrow section, cars move slowly through the narrow area. After passing the narrow area, traffic becomes normal. The one lane section is the bottleneck. The same principle apply in the manufacturing. What is bottleneck analysis? Bottleneck analysis is the process of identifying the bottleneck, understanding its causes, measuring its impact, eliminating or reducing the constraint, improving overall production flow, and the objective of the bottleneck analysis. The goal is to maximize throughput and eliminate delay that reduce productivity. Why bottleneck analysis is important? Bottleneck can causes production delay, low productivity, high inventory buildup, increased cost, missed customer deliveries, excess overtime, poor resource utilization. Benefits of the bottleneck analysis: increase production output, reduce lead time, improve machine utilization, better workflow balance, reduced work in progress inventory, higher customer satisfaction. An understanding of the bottleneck with an example. Consider a manufacturing line. Process capacity per hour. Cutting 100 units, drilling 90 units, welding 60 units, painting 80 units, packing 100 units. Analysis. The welding process can only produce 60 units per hour. Although other department can produce more than the entire production line can only produce 60 units per hour because the welding is the bottleneck. Then types of bottlenecks. So short-term bottleneck. Short-term types of bottleneck. First one is short-term bottleneck. Temporary problems that reduce production. Example: machine breakdown, operator absence, material shortage, power failure. Result: production slowdown for a limited period. Then long-term bottlenecks. Permanent constraint in the process. Example: old equipment, insufficient manpower, poor layout design, low capacity machinery, and result: continuous production limitation. That is sign of a bottleneck. Then sign of a bottleneck. A bottleneck can often be identified by observing the production flow. Common indicator. First one is inventory buildup. Large quantity of material waiting before a process. Example: 500 parts waiting before welding. 500 parts waiting before welding. Only 20 parts waiting before painting. This indicates welding is slower. This indicates welding is slower. Then second one is idle time after the process. Worker or machine after the bottleneck remain idle. Workers or machine after the bottleneck remains idle. Example: painting operator waiting for welding pads. Painting operator waiting for welding pads. In a long-term cycle, the process takes significantly longer than others. The process takes significantly longer than others. Frequent overtime. Employee in one area work overtime while other finish on the time. Low through output. Production output remains low despite sufficient resources. Bottleneck analysis. Step 1. Map the process. Bottleneck analysis processes. What are the process of the bottleneck analysis? Step 1. Map the process. Create a process flow chart. Example: raw materials, cutting, drilling, welding, painting, assembly, dispatch. Then second step is measure the cycle time. Measure the cycle time. Determine how long each process takes. Cutting 2 minutes, drilling 3 minutes, welding 8 minutes, painting 4 minutes, assembly 3 minutes. The welding process requires the larger time. The welding process requires the larger time. Therefore, welding equal to bottleneck. Welding equal to bottleneck. And step B, measure capacity. Measure capacity, calculate output capability. So the cutting 30 units per hour, drilling 20 units per hour, welding 10 units per hour, painting 15 units per hour. Lowest capacity. Welding equal to bottleneck. Welding equal to bottleneck. Analyze root causes. Analyze root causes. Use lean tools such as 5-why analysis. 5-why analysis. Problems: production output is low. Production output is low. Why? Welding is slow. Why? Operators spend time adjusting fixture. Why? Fixture are not standardized. Why? No standard set of procedure. Root cause: lack of standardized work. Lack of standardized work. Then step 5. Implement improvement. Implement improvement. Remove or reduce the bottleneck. Remove or reduce the bottleneck. Pursue to action: add manpower, improve machine speed, reduce setup time, improve maintenance, balance workload, automate repetitive tasks. Example of the bottleneck analysis situation: a Fortuner factory manufactures chairs. A Fortuner factory manufactures chairs. Production: cutting 500, drilling 480, sanding 250, painting 450, packing 500. Observation: sanding procedure only 250 chairs per day. All other process produce more. Bottleneck sanding department. Root cause: only sanding machine, frequent breakdown, manual operation. Solution: add second sanding machine, implement preventive maintenance, the train additional operator. Results: output increased from 250 chairs per day is equal to 450 chairs per day. And lean to use for the bottleneck analysis. First one is value stream mapping. Value stream mapping (VSM) helps visualize material and inform flow. Helps visualize material and information flow. Benefits: identifies delay, find out bottleneck, detect waste. Second one is Pareto analysis based on the 80 by 20 principle. Example: 80% of the production delay come from welding, machine breakdown, and focus improvement effort the past. Then third one is 5-why analysis, finding the true root causes. Example: machine stopped. Why? Motor failed. Why? Bearing damage. Why? No lubrication. Root cause: poor maintenance. Fishbone diagram analyzes causes related to causes related to man, machine, material, method, measurement, environment. Man, machine, material, method, measurement, and environment. Then the fifth one is Kaizen. continuous improvement activities focused on eliminating bottleneck, focused on eliminating bottleneck, and key performance indicator KPI, key performance KPI for bottleneck monitoring. Through output, measure output produce formula through output equal to total unit produce divided by time, total unit produce divided by time, and cycle time. Cycle time required to complete one unit, and lower cycle time indicates bottleneck flow. And lead time. And lead time. The time from order received to delivery. The time from order received to delivery. Reducing bottleneck reduces lead time. And OE, overall equipment effectiveness. Measure machine performance. High OE means fewer bottleneck issue. Utilization rate. Measure how effectively equipment is used. Formula utilization equal to actual production time divided by available time into 100. Actual production time divided by available time into 100. Then strategy to eliminate bottleneck. First strategy is increase capacity. Example, add another machine. Second one is reduce setup time. Use SMD, single minute exchange of die. Benefit faster changeover, higher productivity. Third one is improve preventive maintenance. Reduce machine breakdown. Cross-train employee. Workers can support bottleneck area when needed. Automate repetitive tasks. Example, robotic welding instead of manual welding. And balance the production line. Distribute workload evenly across processes. Real life manufacturing example. An automobile factory has stamping 500 cars, welding 400 cars, painting 250 cars, assembly 450 cars. And bottleneck painting department. Although other department can produce more, factory output is limited to 250 cars per day. Improvement added automatic paint booth, reduce paint drying time, improved scheduling. Results painting capacity increased to 400 cars per day. Overall production increased significantly. And common mistakes in bottleneck management focus on non-bottleneck processes, producing excess inventory, ignoring root causes, lack of performance management, poor maintenance practices, failure to remove bottleneck regularly. In the last point, I will explain that is the conclusion and the end of the point. So the bottleneck analysis is one of the most important technique in lean manufacturing. A bottleneck is the process that limits the overall production capacity of the system. By identifying bottlenecks, analyze their causes, and implementing improvement action, organization can increase through output, reduce lead time, improve productivity, lower cost, and enhance customer satisfaction. Lean tools such as value stream mapping and lean tools such as value stream VSM, 5-point analysis, Pareto analysis, and Kaiser helps organize systematically identify and eliminate bottlenecks, leading to continuous improvement and excellence. And operational excellence. This is my second part 2 video, and this is also bottleneck analysis. What is bottleneck analysis? So see that image that you can clearly understand about that what is bottleneck analysis. So first machine is machine capacity 20 pieces per hour. Second machine BAG machine capacity 5 pieces per hour. Third is 20 pieces per hour. Then what is bottleneck analysis? Understanding bottleneck analysis. What is bottleneck analysis? How to deal with bottleneck? Types of bottleneck analysis. Benefits of bottleneck analysis. So what is bottleneck analysis? Bottleneck is that particular area which restrict the smooth flow of production. Smooth flow of production. Then, what is bottleneck analysis? Bottleneck is that a particular area which restricts the smooth flow of production. Bottleneck leads to loss in revenue, increased waiting time, poor quality products, and lost customers. Why bottleneck analysis is important? So see that image. This is the image and this is the my main point about the loss in revenue. Suppose bottleneck analysis cannot solve this problem, then that problem is the big problem in the future time. So be careful about that. And types of bottleneck, one is short-term bottleneck, another is long-term bottleneck. Short-term bottleneck, types of bottleneck. First one is short-term bottleneck, another is long-term bottleneck. What is bottleneck analysis? Bottleneck analysis is a process of identifying bottleneck, dealing with bottleneck, increase additional capacity, eliminate non-value-added step, added additional workforce, balance production line. Bottleneck analysis tools, hardware analysis, and peaceful diagram, theory of constraint, and common cause of bottlenecks, poor line balancing, inadequate process control, inadequate process control. Now, what is the benefits of the bottleneck? Eliminates waste, streamline process, reduce inventory, minimize poor quality products, reduce downtime, increase overall production capacity. And that is the end of my second video. And let's start about my third video. And this is the most important thing in that topic. Most process most process of the bottleneck, so that every material comes flow smoothly, but this material cannot smooth the process optimization. Built neck analysis will be ready. Bottleneck analysis and Gemba works. Process optimization or bottleneck analysis and Gemba work. Bottleneck analysis. Bottleneck analysis. Identify constraint. Machine 1, machine 2, machine 3. Strategic linear approach for bottleneck identification and their answer. Identify and their purpose. So bottleneck stage in a process that has lowest capacity or higher cycle time and ultimately limiting the throughput of entire system. And then bottleneck strategic linear approach for bottleneck identification and therefore BSM and BSM to visualize the entire end-to-end flow of material and information in a process to compare customer demands and rate compare to compare customer demand rate, tag time with the as fast each process can fast each process and how fast each process can operate at cycle time, and to measure the unit system can produce in the given time frame. So like then track the inventory accumulation and different stages of the process. Then bottleneck stages cycle time equal to one piece divided by 30 minutes highest capacity used. Then current state of the bottleneck, how the value stream mapping helps in identifying how the BSM helps in identifying potential bottleneck and optimizing them towards environment. Current state mapping process data collection line is 60 10 60 10 90 and 20. So see that image that you can easily understand what is bottleneck. And assembly stages, highest cycle time, lowest off time, and highest WIP. So identify bottleneck process using takt time versus cycle time and optimization production flow. So define takt time, customer demand 960 units per day, available working time 8 hours. So takt time equal to available time per customer demand divided 30 seconds 30 units. So return takt time. And you can understand this in picture and how we capacity at different stages helps in identify bottleneck processes. So that's enough for me. Then game power. How we game power helps in bottleneck analysis. The game power means real and actual place. You know, observe the real process and identify who is standing in space. Understand actual program interaction with the whole line. You know how game works in bottleneck analysis. The operator inside real-time observation validation of data. How to also ask bottleneck analysis. Program within the data collection and data and support taken on video. Then Gemba work discovering the data sources. See, that is also bottleneck. So we use the why bottleneck analysis at Gemba work. Paste together when it's hard. Time together bottleneck analysis. I found as five pinpoints of the constraint using the flow flight and validation was usually. So that is the bottleneck and the tools visualize visual stream mapping for that it's all enough for me. Thank you for your support. So, thank you for your listening. If you found this information useful, please like, share, and subscribe to channel for more content on lean manufacturing, industry, and engineering. So thank you for your support.